Okay, so I'm gonna do a video just for the review material first because I feel like this is something that teachers take it for granted a lot, but there are some subtleties and people forget things, and there's some very dangerous traps. So what we're gonna do is we're gonna deal with inequalities. I'm gonna have this first video is gonna be just the review material. This is the just-in-time review, so I'm just calling it J.15. They're 15. They're just one pagers, but they're all very, very important, and it would be a pretty good idea to flip through that and just one at a time, just read what's on the page. And if those problems are super easy and you're getting the same answers with no problem, then you're good. But any one of those review things, if you get the wrong thing, you make a common mistake, and you don't learn how to catch yourself, it can cause you troubles again and again. So we're going to do just basic how do you deal with inequalities. The new secret ingredient, or not secret, but the new twist on the problem, I guess, is we're gonna deal with like linear, like sort of equation of a line, but something like that. But there's one absolute value around a variable somewhere in the problem, which it really adds a new twist to things, and we have to learn how to break that down into stuff that we already understand, and then there's gonna be a few steps involved. But I have a problem just for this. On the other side of the board, I've got problems for both of these, but I want to focus on just the review stuff, and then we'll start a new video when we get to the absolute values. So for now, we're doing that. Okay, so a reminder of what's good and what's not good. Let me start with the two green check marks. Well, in some ways, inequalities work the same way as just equalities, but other ways it's very, very drastically different. But so if you have like A is less than B and you add 2 to both sides, then they were equal after you added 2 to both sides, if and only if they were equal prior to that. So sometimes you just want to find what is x. You want to solve this inequality, x plus 3 is less than 7. Sure, you can subtract 3 from both sides and you get the exact same inequality again. So x plus 3 is less than 7 if and only if x is strictly less than 4. So in inequality, the solution set is usually one or more intervals. So yeah, sure. X could be any number that's less than 7, and so you plug in, x could be any number less than 4. So you plug in 4, it's not true because 7 is not strictly less than 7. But you plug in 3, 6 is less than 7. You plug in 0, 3 is less than 7. You plug in -2, 1 is less than 7. So just one step of algebra, you add a number to both sides. That's never, ever, ever a problem. You can always just add a number to both sides of an inequality. And there's the exact same direction of the inequality. What's easy to forget is multiplication. So the good news is that you can always multiply by a positive number, and you get an equivalent inequality. So if 1/2 of x is strictly less than 2, you multiply both sides by 2, and you get, the picture that you would draw is that if A is less than B, and then you double both of them, then A is still less than B. One or both could be positive or negative, but if you stretch the real number line, everything still ends up in the same order. You don't flip anything. So the solution set here would be x could be any number that's less than 4, and so same thing. You can check. Well, you pick any number that's less than 4, then these two inequalities are either both true or they're both false. So if x is exactly 4, then 2 is not strictly less than 2 because 4 is not strictly less than 4. 7 is not less than 4, and therefore 7 halves is not less than 2 because 3 halves is not less than 2. And that's it for that one. But there are two things that are dangerous. One's a little bit dangerous, but sometimes you have to do this. Or sometimes it's the easiest way to do it, but you have to be very, very mindful of what's the consequence here. Okay, so if you multiply or divide both sides of an inequality by a negative number, you get a new inequality. Maybe I use this for the times symbol. It's not the variable x. There's a couple ways you could deal with this. You could add something to both sides. If you add x to both sides, then add 4 to both sides. That's another way of getting the same result. So if you add x to both sides and you add 4 to both sides, then you would get x is larger than 4. That's one way you could solve this problem. But if you just wanted to multiply by -1, well, the reason that you get the same answer is because you have to remember to flip the inequality, because what happens, let's draw a picture. I already drew one. You have two numbers a and b, such as if a is 1 and b is 4, if 1 is less than 4, then that's the same thing as -4 being less than -1. So sure, a could be 1 is less than 4, but then -1 it's on the other side of the inequality now, because you take the mirror image. So one or both of a or b could be negative. If you take the negative of the entire inequality, anything that's positive becomes negative, anything that's negative becomes positive, or anything that's, if they're both positive, then the one that was more positive is now even more negative, or vice versa. Okay, but the whole idea is if you times an inequality by a negative, you get the mirror image, which means the negative of a big positive number is like a big negative number. So you're super duper negative, which means you're less than all the stuff that was less than you in the mirror image. So it's 10 is bigger than 1, but -10 is less than -1. Just flip the inequality when you multiply by a negative. So that's warning point number 1. This is like a caution thing. Sometimes it's the right thing to do, and you just have to remember one thing. It's really easy to forget if you haven't done it in a long time. Multiply by a negative, you flip the inequality. Multiply by a positive, you don't flip the inequality. Well, what happens if you multiply by a variable or divide by a variable? Just don't go there at all. In this class, we are never ever going to make you solve a problem where that's the only way to solve it. There will be alternative approaches to problems like this, like a quadratic inequality. Like maybe in pre-calculus, there's ways of organizing your thoughts. Usually you would just add stuff to both sides, and then you would factor it, and then you do like a follow-up analysis of various things. But we're not going to go there. You're never ever going to have to do this. Multiplying by x or anything, multiplying both sides by some quantity that you don't know whether it's positive or negative or not, so you don't know whether to flip the inequality because you're multiplying or dividing by a negative, or do you keep the inequality the same because it's positive? Well, that's just a whole basket of worms. It's like you have to, you're just adding more and more possibilities. If you do this, but only if it's positive, and you do that, but only if it's negative, and then it's like, well, now it's too many things. It's just it creates much more problems than it solves, and you just don't ever we're not going to run into any situation where you even want to think about doing that. So you add something to both sides, or you multiply by positive and keep the inequality the same, or you multiply by negative, but don't forget to flip it. Those are basically the three tools for the review problems, and that'll get us pretty far. So let's just do it. So number one, solve it and plot on the number line. So 3x minus 2 is greater than 4. That just means that 3x is, we added, you can add to both sides and that never ever flips the inequality. You're just adding. And then times 1/3 times 1/3. Stop for just a half a second and be like, oh, hey, okay, I'm multiplying by a positive. You don't have to write this down, but you should absolutely be thinking this in your head. At the very least, you're multiplying by a positive number, so we get 2 on that side, and then we have x is still larger than 2 as the solution set. So when x is exactly 2, you should maybe double check you get that they really are equal. When x is 2, you get 2 is not bigger than 2, and therefore 4 is not strictly bigger than 4. You plug in 3, they're both happy. You plug in 1 or 0 or -7, you'll get false. So so solution set, and plotted on a number line. Well, here's infinity, here's 2. You draw the same picture, but you just sketch a quick little number line, and that's the cutoff there. All right, number 2. There's 2 ways you can do this. I'm going to do both. So solution 1. So, okay, 1 minus 2x bigger than 0. -1/2 x is greater than -1. And then times -2 times -2. That's a negative. So this is a big deal. So we had a greater than, now we've got a less than. So -2 times -1 is +2. So x is less than 2. So solution set is an interval from -infinity all the way up to 2. And the sketch on a number line, it looks basically the same. Okay, so that's too bad, I guess. Solution 2 to the same problem is, okay, so we started out with 1 minus 1/2 x is greater than 0. Well, a lot of times you can avoid multiplying by a negative by just adding the whatever it is that's negative, you add it to the other side, and then you multiply by a positive number instead. So times 2. So it's times positive. So times a positive number, left-hand side is the inequality. It's right now it's a greater than. So now we have 2 is greater than x, but that's just saying the same thing as x is less than 2. So x is on the small side. So what does that mean? The work starts out the same way no matter which approach you take, but 2 greater than x means the same thing as x less than 2. And then that's the interval notation, and that's just a picture of the number line. So that's all good. That's fine. So that one's out. That one's done. That one's done. Let's do one more. Number 3. Okay. So we're solving the inequality x minus 1 over all that over 4 is bigger than 1. So that means times 4 times 4. That means x minus 1 is larger than 4, which means that x is bigger than 5. So the answer is the interval from 5 to infinity. So that's the solution set. And number line. Okay, so nothing should go past infinity, but so either I draw like an arrow just to represent the fact that I know that this isn't really going to end, and then infinity is like this idea. Sometimes you see it, the picture drawn that way, but yeah, usually the number line sketches, usually those are multiple choice options, so you'll recognize it when you see it. How do you write it as an interval? Then it's like this. Either you click on this infinity symbol, but I believe \inf on the MyLab tests is like how you start typing it. If I remember correctly, I did this. I did this. It was about a week ago. I was looking at making sure that I had all the right test problems in there, and I wanted to make sure the solutions. I wanted to see what is it that you have to type to make it happy. If you type \inf, then it automatically puts an infinity symbol. There are a few others. I don't remember what it is for union and intersection, but there are a few different commands that can, when you're comfortable with that, it's faster than clicking around with the mouse. It's just you have to, it's one more thing to memorize, but it's pretty cool in MyLab. So that's a little, it's not mandatory. There is a button that you can just click to insert an infinity symbol whenever you need it, but if you're going to have to do this like a couple dozen times by the end of the semester, it's a cool time saver. But that's it. That's old, all of that is old news. But multiplying by a negative, ooh, that's something that you gotta be careful about. So hope that was worthwhile. Don't forget that.